In this video, we are going to learn about differentiability. Right? What is differentiability and how it is important? In the previous video, we have studied about the continuous function. Okay. So the very first, to understand differentiability, we must know what is derivative of a function. So what is derivative of a function? Basically, derivative of a function is the rate of change in any function, right? For example, the rate of change is 2. The function is changing with 2 units, with 3 units, right? How the function is changing itself. It is known as the derivative of a function. Now, we can represent it mathematically as f dash x. This is the derivative. Dash means derivative. It is represented as limit h tends to 0 f of x plus h plus f of x. So it's negative. Change in it is negative, right? Because we represent the derivative as change, so there will be negative sign f of x and it is divided with h. H is the interval basically, right? How it is changing from h to x to h, right? So it is the interval where the function is changing itself. So it is rate of change. Rate of change is represented as the difference. Okay, derivative is basically the rate of change, and rate of change is always represented with a negative sign because it will show the change, variation from one range to another range. So it would be a negative function, right? It would be a negative sign. Now what is differentiation? Process of finding a derivative. Process of finding like how the function is changing itself is known as the differentiation. Every differential function is continuous, but the inverse is not true. Okay, every differential function is continuous, but all the continuous functions are not differentiable. For example, if we take a function which is represented as this, okay, and it will give you at this point it is discontinuous because it's changing itself from this. So here it will be a rate of change because the function is changing itself. So it is not necessary that all the continuous functions are differentiable, but all the differentiable functions are continuous. Now differentiation of important functions, these are very important to solve the questions, right? These are very important because you can directly solve any question of differentiation using these formulas. For x power n, right, we can write it as n x to the power n minus 1. This is the differentiation of xn. For sin x it is cos x, but for cos it would be a negative sin x. For tan x it is sec square x, right? So these are the 4 important formulas, right? Important functions with their differentiation. Now we'll move forward and see, right, how we are going to differentiate a particular type of function. So we must know first of all what is a type of function, and then we'll see how we can solve the differentiation of that type of function. Now here we are having certain types of function and the method we are going to use for the differentiation of those functions, right? This is a summarized table, right, for what type of functions we are going to use which method. So it is very important to understand this because this is a summarized table. If you remember this table, you can easily solve like for what function which method is appropriate, right? Because in exams you will get find the differentiation, so it is your perception like what you are going to use, right? So it is very important to understand these types of functions and the methods of composite function. What is basically a composite function? Composite function can be identified as a function. First is the composite function, right? What is a composite function? It is the combination of two functions, right? If we have f and it is equals to v of u, that means it consists of two functions. The one is v and the second is u. Okay, so we can write ux as t. If we write ux as t, then what we can say is df, differentiation of df and dx is equals to dv by dt, right? Differentiation of v with respect to t and dt by dx, differentiation of t with respect to x, and this t is basically the u of x, right? Now it is better to understand this concept with an example. So we'll take an example here. Let's say f of x is sine x square, right? So this sine x is a one function and x square is a second function, right? So it is v of u. We can write it as v of u of x, right? And there v is what? Sine. And u of x is what? X square, right? So this is u v of u. Now what we do is we'll put u of x as t. So u of x is x square, right? So we'll put x square as t. Now what we have to find? dv by dt and dt by dx. So dv by dt, that is sine of t, differentiation of sine of t, right? dv by dt. So what is dv by dt? It will be sine x differentiation is with respect to t, it is cos of t. This is first. Now similarly, this is your t, so dt by dx, okay, differentiation of x square, that is differentiation of x square with dx. So this we have studied earlier. What is the formula? Twice of x, 2 minus 1, so it will give you 2 of x. So this is your equation number second. Now we know that df by dx is dv by dt and dt by dx, right? So now this is equation third. This is your equation third. So I will what? I'll put 1 and 2 in third, right? So what we get? df by dx is equals to twice of x cos. So this t is again, what is this t? T represents, what is this t represents? X square, so it will be x square. So this is your basic answer, right? You have to just combine dv by dt and dt by dx by putting ux is equal to t. So this is the procedure how you can solve the chain rule, right? Chain rule. Now let's move forward and understand what is the implicit functions, right? And how you can solve the implicit functions. Basically, what is an implicit function is, if it is not the equation is not written in the standard form. For example, what we have studied is fx is equals to x plus 2, right? And this can be represented y is equals to x plus 2, right? So this is your standard format. But what if it is given as find dy by dx of y is equals to y plus sin y is equals to cos of x. So this is an implicit functions because y and x, okay, so it is not given as y is equals, it's not in the standard format. So how you are going to solve this? For this we have to do very simple thing, that is taking, okay, this is your equation. First differentiate first both sides with respect to x, right? So what we can write it as, it is dy by dx plus d sin y by dx is equals to d dx, that is cos x, right? So this you have to do. Right? So you have to write it as dy by dx, dy by dx, right? Here you can write it as sin y is cos y, but here you can write dy by dx because it is with respect to x, so you have to write it as dy by dx is equals to cos x differentiation is minus sin x, right? Here it is with respect to x, so dx by dx is 1 only, so here we will write it as cos of y dy by dx because here it is in terms of y, not x, okay? So now we will take dy by dx is 1 and 1 plus cos y, and here it is minus sin x. So how you will get the answer as dy by dx is equals to minus sin x 1 plus cos y. So what you have to remember is, if you are differentiating with respect to x and here you are having a different variable, that is y, so you have to write it as, we'll differentiate it but we'll write dy by dx because it is with respect to x, right? It is, if it is with respect to y, then you can simply write it as cos y, but it is with respect to x, different, the variables are different over here, so you have to write dy by dx. So this is your basic solution or answer of this question, right? Now for inverse trigonometric functions, it is very simple. For inverse trigonometric functions, you have to remember the formulas, okay? So I'll display you the formulas, how you can, okay? So we'll talk about this later on, okay? But first we'll understand the function if it is given in the form of ux to the power vx. Okay, how you are going to solve this type of functions. Now let us understand what is logarithm differentiation, right? If any function, we take, to understand logarithm differentiation, we must understand certain properties of logarithm. For example, let us take an example, y is equals to x sin x, right? Now there is certain properties of log. So the very first property of log says, if x square right? And we do log of x square. So this 2 will come 2 of log of x. Okay, so this is the first property of log. Secondly, if we have any multiplications, like if we have log of x and we have sin x, right? So this can be changed into sin x, right, plus log x. So this multiplication will become addition. Okay, let's understand it with, if we take log x minus 3 and x minus 2. So this multiplication will change into addition. Okay, so what we can write it as, log x minus 3 plus log x minus 2. So this is the second property. For third property, if we have log x by 3 and x by 2, if we do this, okay, so this can be written as log x minus 3, and it would be a minus log x minus 2. Okay, so division will change into subtraction. So these are the three properties. This is for power, this is for multiplication, and this is for division. Okay, for this question, what we are going to do is, we are taking y, we are taking log both sides. Okay, we can write it as log of y is equals to log x sin x. So this will change into sin x and log of x, right? You will change it into this. Now we'll do the differentiation, right? If we differentiate both sides, right? We are going to differentiate both sides. So differentiate both sides. For this differentiation, you must know log of x, right? If we do dy by dx, what we get? 1 upon x, right? We get the answer as 1 upon x. So if it is a y, with respect to dx, you have to differentiate. So what you can write it as, d by dx of log y. Here d by dx of sin x log x, right? So here you can do the differentiation 1 upon y dy by dx, because it is with respect to x. For this log, it is two function, it is u and this is v. So here we will apply the chain rule. So it would be, first we will take sin x and we will do differentiation. So here you can write it as Here you can write it as sin x log of x is 1 by x, right? So it would be dy by dx of log x, right? Here plus log of x into d by dx of sin x, right? So you can write it as 1 upon y dy by dx, and this is 1 upon x sin x, right? Here you can write it as sin x is cos x, so it would be log x and it would be cos of x, right? Now you know dy by dx is, we'll simply divide it with, we'll multiply it with y. So what we get is dy by dx is equals to y. And what is this y? This is first. Okay, it's y sin of x by x plus log of x into cos of x. Right? Now put this from equation 1. This y is x of sin x. So this is your answer. So there are very important properties in this question, right? So the very first is properties of log. Then you have properties how you can solve these two composite functions. Okay, so this is your second property. Like take this and do the differentiation of the second one. We'll take second and we'll decide the differentiation of the first one. So this is how you have to differentiate the two x's. Okay. Now the fourth one is the differentiation of inverse trigonometric functions, right? So in this you have to just remember the formulas for the inverse trigonometric functions, okay, which is on your screen. You can just take the screenshot of this inverse trigonometric functions and you can remember it, because it is nothing to do with the explanation. You have to just memorize these trigonometric functions, okay, like what is the differentiation of sine inverse x, cos, right? So you just have to memorize this one. So it is very similar to each other. There is only certain differences, right? You have to remember whether it is a positive or it is a negative. Okay, for sine inverse x it is 1 minus x square. For cos inverse there is only difference is negative. For tan and cot, right, for these two it is similar formula with negative as the difference. Similarly for sec and cosec we have same formula with the difference as modulus, right? You have to take mod of x, here you don't have to take the mod of x. Okay, now we have come to the end of this video. Okay, we are going to understand the two important theorems of differentiation, that is the mean value theorem and the Rolle's theorem, right? So let's understand these two theorems. Right, on the screen we are having two theorems, that is the Rolle's theorem and the mean value theorem. What is Rolle's theorem states that if we have a function f, right, we are having a function f and f is a continuous function in closed interval a to b. If a function is continuous between a and b, right, we have a continuous function between a and b and f is differentiable at a and b. What does this closed interval means? Closed interval means it should be continuous from a to b. So it should be continuous at a itself, right? It should be continuous from a to b. So it should be continuous from a to b. It should be differentiable on open interval, means you can exclude a and b. A and b, it can have up to c and d, right? So it should be a differentiable function from a to b and a continuous function from a to b then f of a is equals to f of b. Okay, f of a will be equal to f of b. There will exist a number c. This is important. This part is very important to understand. There will exist a number c such that f dash c. If you will differentiate c, you will get the answer as 0. Okay. If you will differentiate c, you will get the answer as 0. So if you differentiate any function at particular point, you will get the answer as 0. So this is the Rolle's theorem, right? Now what is the mean value theorem? Mean value theorem says that if its function is continuous and it is differentiable, then there will exist a mean point, right? There will be f dash c, which is f of b, rate of change from f of b to f of a, right, divided with b minus a. So this is your mean value theorem, and this will be your mean point, right? It could be a mean point, that is the, so this is for your Rolle's theorem, this is for your mean value theorem. Okay, so these are the two theorems where you have to memorize the outcomes or the result of these two theorems, what they state. Okay, so this completes your differentiability. Thank you for watching.